Hi everyone, today I'll be looking at graphs and I will be discussing the worksheets that you should be going through in your tutorial. Let's get started. So the first one, plot the graph of the function y equal minus 2x squared plus 7 for x is greater than or equal to -3 but less than or equal to 3. Now, this is a range that tells us what we need to have in our x-axis. So we need to get a table so that I can get my x and y values to plot. So always look out for what's the range. So we have -3, we have -2, we have -1, 0, 1, 2, and 3. Now, if you have your calculator, you can use your calculator to calculate what are the values. So what we are going to do is replace x with -3. So we have -3 and we square it plus 7. So -3 square, don't forget that when you square a minus number, it is going to be positive. So we have -3 squared, that is 9, times 2, but because of the sign, it will be -18. So -18 plus 7 to give me -11. So I'll have -11 for my first y value. So it means when you're plotting, you're going to plot x is -3 and y is -11. For -2, you're going to do the same thing. So instead of having -3, we have -2. When you square -2, that's +4. And 4 times -2 is -8 plus 7. That's going to give you -1. Then we substitute x equal -1. So replace -1 here. -1 square is +1 times -2. So that's going to be -2. So -2 plus 7, that gives me 5. Now, when x is 0, what happened? This is going to disappear. So I'll have a 7. Then we substitute x equal 1. So 1 square is 1. 1 times -2, that's -2. -2 plus 7, that gives us 5. Then we substitute x equal 2. So for x equal 2, we have 2 square is 4. 4 times -2 is -8 plus 7, that's -1. And x equal 3 is going to be 3 square is 9. 9 times -2 is -18 plus 7 to give us -11. So we are going to plot -3, 11, -11, -2, -1, -1, 5, 0, 7, 1, 5, 2, -11, 3, -11. So let's look at how this graph will look. So if we are going to plot -2x squared plus 7, this is how the graph will look. This is the shape. So if you realize it's a -2x squared. So once it's negative in front of the x squared, it's going to be a maximum curve. So here you can see that's a maximum curve, and this is the parabola that we should be getting after you have plot. So go ahead and pause the video and you can plot on graph paper. Use the scale that you desire. You don't have to say, oh, which scale I'm going to use. Just ensure whatever scale you use on the x and y axis can hold all the points that we have. So this is the graph you should have when you have plotted it. It should be looking like this. So once you have plotted the points, this is it. And here you can find the maximum y value. So the question asks, using the graph, find the maximum y value. This is where the turning point is, and it is at 7. Let me zoom in. So you can see it's at 7. So that means your answer for this is y equal 7. Now, the next part says, let me zoom a little bit in. Solve the equation f of x equals 7. Now, f of x is just this function. So this function equals 7. And f of x is the same thing as saying y equals 7. Now, y equals 7 is a horizontal line going through the axis. So if I'm going to find out what it is, let me go ahead and get a line. So you should be using your ruler. Freehand to draw a curve, but a ruler to go ahead and draw the line. Let me get it a little bit thicker. So this is my line. And as you can see, it's right at the turning point for y equals 7. So in this case, we have one x value. And if you can see, when it's intersecting at y equals 7, so y equals 7, and you go down, it would be x equal 0. So therefore, my answer for this is x is equal to 0. So where the line and the curve meet at this point, it's 1 point. My answer is x equals 0. This solve the equation 7 minus 2x squared equals 0. This is the same thing as a function. It's like saying minus 2x squared plus 7 equals 0. And by right, this is the same thing as saying f of x equals 0. And f of x is the same thing as saying y equals 0. Now, y equals 0 is the x-axis, so we need to go ahead and read off what's the points where it cuts the x-axis. So let's zoom in a little. So if you look at this, it's not directly on this line. So we know that this is 1, so this is 1.2, 1.4, 1.6, 1.8, but it's not directly on the 1.8 line. There's a little space, so let's say this is x equal 1. Let's say 82. Now over this side, once again, this is negative 1.1, 1.2, negative 1.4, negative 1.6, negative 1.8. This looks like negative 1.9. So I'm going to say x equal negative 1.9. So for this activity y equals 0, we read off where the curve cuts the x-axis and it gives you the x values. For the next one, we have minus 2x cubed minus 3 equals 0. So I'm going to write it over this side. We have minus 2x cubed, minus 2x squared minus 3 equal negative 8. So looking at the next one, we need it to be minus 2x squared plus 7. So in order for it to be minus 2x squared plus 7, I will have to rewrite it so that this becomes a plus 7. Now, what you can do, you can think of, either you carry this over, then you think of what to do to make it become 7. Or, what do I need to add to minus 3 so that it becomes positive 7? So you think about it. What can I add to minus 3 so that it becomes 7? Think about it. I'm hoping that if we're seeing if I add 10 on both sides, because anything you do to one side, you have to do to the other side. So you have minus 2x squared, and I will add minus 3 plus 10, that's plus 7. And minus 8 plus 10, that's 2. So when I add 10 to both sides, I will get my plus 7. So it becomes minus 2x squared plus 7, which is what I have here. So this is the same thing as saying y equal 2. So what is y equal to? We are going to draw a horizontal line through 2. So this is y equal to, you draw a horizontal line through 2. This is y equal to. So let me zoom in a little. So where the line and the curve meets, we have to read off the point of intersection. So we have 1 here, and this is not directly on the line, so it's right here. So just reading what is my x value. For this one is directly on this line. So negative 1.2, negative 1.4, negative 1.6. So this is x equal negative 1.6. While for this is 1.2, 1.4, and it passed 1.5 close to 6. So I'm going to say negative. This is going to be x equal 1.5. I'm going to say 8 because it's almost reached 6. So here I have my x values when we have y equal 2. And that's how you answer the different parts. Let's look at another graph. So here we have another graph, which is, we need to plot the graph of the function gx equal 2x squared plus 3x minus 3 for x greater than or equal to negative 4 but lesser than or equal to 3. So this is what we use to create a table. So we always need a table. So we have negative 4, we have negative 3, we have negative 2, we have negative 1, we have 0, 1, 2, 3. Now, y value, we have to go ahead and substitute it in gx. And of course, using your calculator is allowed to speed up the process to find the y values. Now, just remember when you're squaring a number, it's going to be positive, so don't forget that concept. So when x equals negative 4, I am going to replace where I have minus 4. Where I have x, I replace it with minus 4. So we have minus 4 squared, so that's 16, positive 16 times 2, so that's 32. 4 times 3 is 12, so that's minus 12 minus 3. So that's 32 minus 12 minus 3, so that's 17. So my answer is 17. So I'll have a 17 right here. So we're going to do the same thing when x is negative 3. So where I have x, I replace it with minus 3. And we go ahead and work out the values. So negative 3 squared is 9. So 9 times 2, that's 18. Minus 3 times negative 3, that's negative 9. And then we have minus 3. So we have 18 minus 9 minus 3, that's 6. So the answer in this case will be 6. So I have a 6 here. Now we're going to do the same thing when x is negative 2. So we replace here to be minus 2. So minus 2 squared is 4. 4 twos 8. 3 times minus 2, that's minus 6. So 8 minus 6 is 2. 2 minus 3 is negative 1. So I have a negative 1 here. Then we're going to do an x equal negative 1. So x equal negative 1, we have negative 1 square is 1, 1 times 2 is 2, 3 times minus 1 is minus 3. So we have 2 minus 3 minus 3, that's negative 4. When x is 0, all of this is gone, so you're just going to have a negative 3 here. When x is 1, so we are going to move the minus. So when x is 1, we're going to have 2 plus 3 minus 3. So this is gone, so my answer is 2. When x is 2, we're going to have 2 here. So I have 2 2's 4, 4 2's 8, 3 2's 6, minus 3. So we have 8 plus 6, that's 14, minus 3, so that's 11. And then when x is 3, we substitute 3. So 3 squared is 9, and 9 2's 18. So we're going to have an 18 here. 3 3 is 9. So it's 18 plus 9 minus 3, so that's 24. So this will be 24. So now you plot the graph. So let me go ahead and go into the graph. So because x squared is positive, this is how the graph would look. It'll be a minimum curve. So remember we did x equal negative 4. So you'd have 17 here. When x is negative 3, you would have 6 here. When x is negative 2, you would have negative 1 here. X is negative 1, you would have negative 4. When x is 0, y is negative 3. When x is 1, y is 2. When x is 2, y is 11. And when x is 3, y is 24. Alright, let's go back. So this is a graph that we look. I just took a picture of it so that we can answer some of the questions. So this is not the full diagram, but this is enough so that we can do the activities at hand. So using your graph, solve the equation gx equal 10. So gx equal 10, what is that saying? So what's happening here is that for gx equal 10, it's like saying y equal 10. So once again, I need a line. So I am going to draw a horizontal line going through 10, ensure it cuts the curve. Not just any simple line, but we need a horizontal line going through 10. So this represents a line y equal 10, and you can see that it cuts it at 2 points. So I need to go ahead and find out what's this. So we draw a line going down the x-axis. Same thing here, draw a line going down x-axis. Line is a little bit lean. Of course, you should be using your ruler to ensure that you draw a very straight line. So looking at this, this is 1 and this is 2, so this is 1.2, 1.4, 1.6, 1.8, so it'd be x equal 1.9. Over here, this is negative 3, negative 3.2, negative 3.4, so this is x equal negative 3.4. All right, the next one we have is 2x squared plus 3x minus 3 equals 0. This is exactly the same as the graph that we just draw. So this is the same thing as saying y equals 0. And I would ask you, what is y equals 0? I'm hoping you're seeing where the graph cuts the x-axis, because the x-axis is y equals 0. So we need to read off where the curve cuts the x-axis. That's where we read. Let me go ahead and zoom in. So this is -2, and then right here would be 2.2. So this is x equal -2.2. Let me just redraw this line because it's really in between. So it looks like it's in between. So if this is 0, this is 0.2, 0.4, 0.6. Let's say x equal 0.7. So this would be the value for when y equals 0. Where it cuts the x-axis, you read off what's there. Once again, this is looking like the function we have above. So that means we are going to look for y equal 2, which is this number. If I say to you, what is y equal to? I'm hoping you're saying that it's where it cuts the y-axis at 2, which is right here. So once again, you are going to read off the point of intersection, and for this activity, I'm not going to give the answer. I want you to pause the video and state where I cut, what is my x value, and write it in the comment section. What is x value for this? X equal what and x equal what? What's this value? What's this value? This is a key one. I'm very interested to see in the comments. What do you have? The next one we have 2x squared plus 3x plus 1 equals 0. So for here, the plus 1 needs to be changed because you have -3. So if it is plus 1 and I need -3, you need to say to yourself, what can I add or subtract so it becomes -3? So given that I want -3, then it means you have to subtract 4 from both sides. Because you'd have 2x squared plus 3x and 1 minus 4, that's -3, equal -4. So that means that's y equal -4. So in this case, I'm going to go to the graph because I'm going to allow you to tell me in the chat what is y equal -4. So by right, this is y equal -4. So let me go ahead and switch. And I'm going to zoom in a little. This is -4. So you would draw a horizontal line through -4. And where the line and curve meets, we need to read off the values. So the greatest thing with this, I'm able to see what is the x value. So this is going to be, you go ahead and state it. And then I want you to state what's this one. So looking at my graph, you need to figure out what is the value of x for this one. We know x is -1. It's clearly stated here. But what about right here? What would you see is the x value here going up to the axis? So go ahead and state that in the chat. Now we're going to look at a different type of graph, which is called a piecewise function. So this is a piecewise function, and the next one that we're going to look at, this is also a piecewise function. So we have two piecewise functions that we are going to talk about. Let's look at the first. So we're going to plot the following graph. Now, what this is saying, for x lesser than or equal to 0, we have pi, where between 0 and 7, we have x plus 1. For x greater than 7, we have 1. So we're going to plot this. First thing first, pi, we can just run it off to be 3.14 or 3.1 for the sake of properly plotting it on the graph. Now, the next thing, if it says a number, it's just like saying y equal that number. And when we say y equal number, say for example y equal 2, would have said draw a line through the y-axis at 2, a horizontal line. But for the piecewise function, this tells you where you should start your line. And it tells you how far does your line go. So given that it says x lesser than or equal to 0, the equal to means that we're using the number 0. And from set theory, if we're using it, we would have a shaded circle to say it's closed. We're going to use that same information here, where let's look for 3.1. So just zooming in. So 3.1, this would be 3.2, so that means 3.1 would be in between here. So having this dot now, I know that's where I'm going to start because this is where I have x is 0. But it says less than, so it means I need to go on to minus infinity. So I'm going to get a little line and I'm going to draw a horizontal line going towards negative infinity. So this is a line and it's shaded. Now the next one we have is x plus 1 between 0 and 7. This is a line. And with a line, we need coordinates, right? Once it's a line, we need coordinates. And guess what? We have to create a table and we need a ruler to connect them. If it's called a power, then we would have used freehand to draw the curve. But x plus 1, no power, so that's a line. So we have our table, x and y, and the numbers are 0, 1, 2, 3, 4, 5, 6, 7. So for x equals 0, put 0 here. So 0 plus 1 is 1. X equal 1, 1 plus 1 is 2. X equal 2, 2 plus 1 is 3. X equal 3, 3 plus 1 is 4. X equal 4, 4 plus 1 is 5. X equal 5, 5 plus 1 is 6. Then this would be 7, and then we have 8. So these are the ones that we're going to plot, but at 0 and 7, you're seeing that we're not using them. So it means we need to have an unshaded circle here. So let's plot the next function. So we have at 0 and 1, just a normal, so at x equals 0 and 1, 0 and 1, we have our open circle because we're not using 0 and 1. Then x is 1 and 2, so you have 1 and 2, just plot as normal. X equal 2 and 3. X equals 3 and 4. X equal 4 and 5. X equal 5 and 6. 6 and 7. 7 and 8. Then we connect them. So this would represent the line. The next one, we have x is greater than 7. So this is really saying x is greater than 7. So if you don't like how it's written here, you can always just rewrite it as this. So always start reading it as x. X is greater than 7. Because it's not equal at 7, look for 7 and it's at 1. Remember, this is like saying y equal 1, but it's just saying we need to start that line at 7. So this is y equal 1, and we are going to draw the line, and it goes on to positive infinity. So it never ends. Alright, so this is better. So these are the three functions, and let's go on to answering the graph graphically, and then we can look at, the other parts where we can solve it otherwise. So if I'm going to solve this graphically, h of -1, you look for x equal -1. So h of -1, x is equal to -1. So you look for -1 and you go up to the x-axis. You look for x equal -1 and go up to the graph. Where it cuts the graph, we know that this is pi, so we can see the answer is pi, or 3.1 or 3.14. The next one we have is h of 1. So for h of 1, this is saying x is equal to 1. So when x is equal to 1, this is x equal 1, we are going to go up to the graph where it cuts. So that means our answer is 2. Y is equal to 2. So that's the answer. HE. So let me erase this. So E has a value. E is 2.7 and a lot of numbers, but we're going to use E to be 2.7. So when we have HE, we can say, okay, let's find H of 2.7. So we need to look at where is 2.7 on our graph. So I'm going to zoom in a little. This is going to be 2.2, 2.4, 2.6, 2.7 is in between. And I'm going to use my little line to help me to draw a straight line. So we draw a line going up. And where does it cut it? Then we continue to draw another line going across. And from this, we can say this is 3.2, 3.4, 3.6, almost 3.7. So let's say 3.65, because it's not necessarily in the center. So it's not really in the center. So let's say 3 points. So I'm going to say 3.65. The next one we have h of 0. So we have h of 0. That means x is 0. So when x is 0, what is y? So we would not use this first value, but the next, which is this shaded one, which would be pi, because it's using it. So the answer would be pi. If I want h of 7, that's saying when x equals 7, but let's look at this. At x equals 7, this function is not using it, and this function is not using it. So my answer would be undefined because there is no answer here. So it's undefined. The last one saying h of 12.5, and as you can see, that means x is equal to 12.5. And for 12.5, it would fall further on, but this line continues to positive infinity. So somewhere along the line, I'll find 12.5. When I go up, it cuts this line, and this line represents what? Y equal 1. So that means my answer is equal to 1. Now we can solve this without having the graph. So without having the graph, we can solve this. So let's redo this by using the piecewise function. So solving this using the piecewise function, h of negative 1. So for h of negative 1, basically what would happen at negative 1, it would fall in this range because this say x lesser than or equal to 0. So since x equal negative 1, it would fall in this range. So that means my answer is pi. For h of 1, 1 would fall in this range. So x equal 1. It would fall in this range, so I have to use this function to find my answer. So replace x to be 1. So 1 plus 1 to give me 2. The third one, h of e, but remember we said we use e to be 2.7. And 2.7 would fall in this range. So replace x to be 2.7. So I'll have 2.7 plus 1 to give me 3.7. H of 0, this is using 0. So that means my answer would be pi. H of 7, none of them is using 7 because none of them have equal to. So this one we said would have been undefined. And 12.5, remember we said this is saying x is greater than 7. So by right, x greater than 7, it means this would be the answer. So my answer would be 1. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.